Welcome to ClickMyProject.com.
Now we are going to discuss about the product applying a random projection algorithm to optimize the machine learning model for breast lesion classification. Now we are going to discuss about the abstract of the process. Since classification between the malignant and benign lesion is a difficult task which depends upon the optimal fusion of many image features related to the tissue density, heterogeneities, and then the other lesion boundaries as well as the variations of the surrounding tissues. Previous studies have demonstrated that statistic and texture features can be used to model the variables in image features including such as intensity, energy, entropy, and other statistical moments. Hence this process is developed to earlier prediction of breast lesions reductions in digital image processing. Hence this project has followed the steps like the preprocessing, feature extraction, and classification. By using these three steps, we have designed the project to classify whether the breast region having the lesions or not. If it is a lesions means we can able to find out whether the lesion is benign or malignant. Now we are going to discuss about the overall working flow of this process. This is the overall working flow. Hence the flow diagram consists of the steps like input image, preprocessing, segmentation, feature extraction, classification, and performance analysis. At first the input image is taken from the dataset. The dataset consists of the several breast lesion images both having the benign and malignant. After getting the input image, we move on to the preprocessing. In this preprocessing, we have done the step like image resize. Image resizing is to resize the image into an optimum size of 256 cross 256. Hence the 256 represents the row and then the next 256 represents the column. After resizing the image, the segmentation will be done. In this segmentation part, the morphological algorithm is applied to segment the affected portion, hence the lesion portion. After the segmentation of the lesion portion, we have to extract the feature from the image. In this feature extraction, we have two kinds of feature extraction. One is GLCM and then the another one is PSA. GLCM represents the gray level co-occurrence matrix, then the PCA represents the particle principal component analysis. After the extracting of the feature, we move on to the classification step. In this classification step, we have using the support vector machine for the classification to classify whether the input having the lesions or not. After the classification, we have to estimate the performance analysis by means of the accuracy, sensitivity, and specificity. Based on these three parameters only, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015b and change the current directory. Now you can see the file in the name of main_gui.em. Right click in that file and select option run. Now the initial GUI was opened, that is the graphical user interface. In that you can see the several axes in the left side for the displaying purpose and then the several push buttons in the right side for the controlling actions. At first click the button input image. After clicking the button input image, it will directly go for the dataset folder. In that select any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After getting the input image from the dataset, the resized image is shown in the axis 2 with the title resized image. Hence in this step we have resizing the image into an aspect ratio of 256 cross 256. After the image resize, we move on to the segmentation portion. In this segmentation step, we have to extract the lesions portion separately. Hence, this image shows the edge image, that's the boundary of the image. This is the segmented image. After extracting the lesions regions from the image, we move on to the feature extraction. In this feature extraction, the extracted feature is shown in the table 1. Hence, this is the value for the feature extraction. Here we are applying the GLCM and PCA for the feature extraction. After extracting the features from the image, we have to open the Python by clicking this button. It will take some time to open the Python directly. Hence, the Python will be automatically loaded, then open automatically. After opening the Python, we have to change the current directory. After changing the current directory, we directly execute the process, means the feature will be processed and then the classification results will be generated. Now the feature will be processed, hence the classification result is shown as a malignant or benign. Hence, in this process, the input having the type of malignant. And then we just move on to the Matlab portion. In this Matlab portion, one file will be generated in the name of the result. It will automatically generated whether the input having the malignant or else the benign. After that, we just click the button next. Now you can see the another GUI. In that you can generate the result by seeing the identified as malignant. Then the performance estimations will be shown to describe the accuracy, sensitivity and specificity.
Thanks for watching this video.